Today we are going to discuss the technique of how to answer Stpm chemistry for chapter 1, thermochemistry. So as usual, we start with the objective question first. So I hope that you all are ready with the solutions. And so now I'm going to show you on how to answer. Yeah? Okay, number 1. Which of the following best explained by the relative strengths of intermolecular forces in between HF, HCl, HBr, and HI in liquid state? Okay, so now what we are measuring here is actually intermolecular forces. Okay, so when it comes to the intermolecular forces, we can measure their what? Okay, we can measure their melting point, boiling point. Okay, so it has nothing to do with the bond energy. Okay, nothing to do with the enthalpy change of formation, and nothing to do with the enthalpy change of neutralization, because all these are involved in the breaking of the HX. So no, we are not going to break HX. We are still going to maintain the HX. We just study what is the intermolecular forces between HX and HX here. So the best solution here is enthalpy change of the evaporation. Okay, so the answer is C. Okay, then we go to the second questions. Variation of the lattice energy of three groups, light, salt, X, Y, Z in the group. So this is it. Which of the following could be X, Y, Z? Okay, so you see that our lattice energy is increasing, isn't it? So in another word, we say is that lattice energy is directly proportional to the charge, yet inversely proportional to the interionic radius. So you must have a high charge and small ionic radius. Looking at all the choice in here, they are all group 1 and group 17 element, isn't it? So the charge is definitely going to be the same, which is 1 and 1. So we are going to look from the radius. So when going up, so you have lithium, which is the smallest, then sodium become larger, potassium become larger. Okay, then in terms of the group 17, we have the Cl is the smallest, then we have Br minus, which is slightly larger, and the largest is actually I minus here. Okay, so in the terms of combination, which one will be the best selection? So if you look carefully, Lii small and large, NaCl medium and small, KBr this one and this one. So X is unlikely going to be the choice. Okay, okay. Then the X here smallest is NaF. Okay, so yes, NaF may be the small one among the smallest here. Okay, so F is even smaller. Okay, so smaller means that you have a higher lattice energy, isn't it? So B is definitely not our choice. So we start from C. Ki is the among them is the largest. Okay, therefore the one with the lowest lattice energy. Okay, then we have LiCl. Then we have NABr. So it is not going to be that. So C is not our answer. Then last but not least, we have NAI, which is the largest. NaCbr becomes smaller. LiBr becomes the smallest. Okay, so in here, the one that suits the trait here is donkey. Okay, okay, so that is why the answer in here is D. Okay, so with that, that is how you answer question number 2. Then 3, which of the following is true about the Born-Haber cycle? 1, it can be used to calculate lattice energy. Of course, it can use to calculate lattice energy. And then number 2, so number 1 is correct. Okay. And then number 2, it start with the reaction that involve only element, not necessarily. Okay. Because when we start the lattice energy, we usually start from, we can start any place that we like actually. Okay. And it can be related using Hess law. So as I told you was this Born-Haber cycle is actually the advance of the Hess law. So of course it can be really using Hess law, and it can use to determine the reactivity of the reaction. No, Born-Haber cycle does not determine the reactivity of the reagent. So the answer 1 and 3 is correct. So the best answer here is B. Number 4, which of the following equation correctly represent enthalpy change of atomization? So what is the definition of enthalpy change of atomization. It is the energy absorbed from one to form 1 mole of gaseous atom from its element under standard condition. So potassium is a solid under standard condition. So solid, potassium solid become potassium gas is the atomization. So the best answer in here is point B. Then we go straight away to question number 5. Going across the series Ki, Kbr, Kcl, Kf, the lattice energy become more exothermic. So this is due to why is the lattice energy. So in here you have a few relationships. The first relationship can be related in such a sense that enthalpy change of solution is equals to hydration minus lattice energy. So in here the enthalpy change of the hydration is going to influence a lot in the this lattice energy. Okay. So number 1 is correct. Not ionization, the lattice energy. I is typing error. Sorry for that. Okay, then number 2, ionic characteristic of the compound increase. So in the lattice energy, it has no relationship with the ionic characteristic or whatsoever. It is straight away the way of how we relate the here we said lattice energy is directly proportional to the charge, yet inversely proportional to the total ionic radius. Okay, so some of them, even though you have a high charge and small ionic radius, doesn't mean that it has a high ionic characteristic. No. So number 2 is wrong. And then number 3, since the lattice energy is directly proportional to the charge and inverse ionic radius, so the anionic radius decrease. Okay, so we're going down here from Ki to Kf. So number 3 is correct. And then number 4, enthalpy change of formation also increase, which is also correct because it becomes smaller. Okay, so with that, the best answer here is 1, 3, 4. C. Okay, so that is for number 5. Okay, so hopefully no problem. So if no problem, then we go to question number 6. Dinitrogen tetroxide is a dimer. It's the dimer formed from nitrogen dioxide. The enthalpy change of the formation of N2O4 and NO2 are 9.7 kJ and 33.9 kJ per mole respectively. Calculate the standard enthalpy change in kJ per mole. So this one is a very quick solution. So simply use total enthalpy change of the product minus total enthalpy change of the reactant. Substitute the value. Positive 9.7 minus 2 times negative 339. So you have enthalpy change of reaction is equals to negative 58.1. So the answer is B. Okay, then we go for number 7. Energy level diagram for the combustion of ethane is given below. So let's together study the cycle. Okay, which of the following is not true? A. Enthalpy change of formation of ethane is negative 364. Okay, so let's together see which one is the enthalpy change of the formation. So the formation is the from where to where? Enthalpy change of formation is from this one to this one. 2C plus 3H2 plus give C2H6. Okay, so this is the enthalpy change. And how do we calculate from here? So you can see from here, Hess law stating that enthalpy change of reaction is the same from one step to series of steps. So it's like A plus B is equals to C plus D. Okay, then you can straight away calculate using the answer in here. So here you have negative 1280 equals to negative 786 plus negative 580. So enthalpy change is negative 364, which is correct. A is correct. Okay, and then B, standard enthalpy change of combustion is negative 286. So which one is the enthalpy change of combustion? So from here we can tell that enthalpy change of combustion is the for hydrogen is for this one. Okay, 3H2 plus 3 over 2O2. So this one you divide by 3. Okay, so you get negative 286. And then C, standard enthalpy change of formation for carbon dioxide is negative 786. So this one, 786 is 2C plus 2O2 give 2CO2. So in here you must divide by 2. Okay, so it's negative 393. So C is wrong. And then summation of enthalpy change of combustion, carbon hydrogen is the same of enthalpy change of formation and combustion. So in another word, A plus B equals to C plus D. So statement D is also correct. So the best answer in here, because we are looking for not true, these statements, we are looking for not true. So the best answer in here is C. Okay, so this is question number 7. So it goes to question number 8. Diagram below show one table cycle for the formation of the sodium chloride. So this is the cycle. What is the electron affinity in kilojoule per mole of chlorine atom? Okay, so you have to calculate eventually. So you use total enthalpy change of formation is equals to total enthalpy change of the lattice energy plus atomization of sodium, atomization of chlorine, and ionization of energy for sodium, first electron affinity of chlorine. So because we are looking for first electron affinity, so press your calculator, you get how much? You get the answer as negative 389. So the answer here is A. So very, very straightforward questions. Okay, so hopefully you know how to relate the equations. Okay, so this is how you solve for question number 8. Okay, number 9. When 1 mole of potassium chloride solid is dissolved in water, enthalpy change given is positive 430. Given the enthalpy change of hydration of potassium ion and chloride ion are negative 308 and negative 421 kJ per mole respectively, calculate the enthalpy change of formation for lattice energy of potassium chloride. So in here you have to use the formula. Enthalpy change of solution is equals to hydration minus lattice energy. So you press your calculator, positive 430 equals to negative 308 plus negative 421. So after you press your calculator, you get your answer as negative 744. Okay, it seems that the answer in here is not in our choice. I apologize for that. So in here, I will just delete off this question later. Sorry for that. Okay, but this is how the way that we solve for question number 9. Okay, so that is for question number 9. Question number 10, which of the following cation has the highest hydration energy? So in order to have the highest hydration energy, we say that enthalpy change of the hydration is directly proportional to the charge, okay? Yet inversely proportional to the ionic radius. Okay? So here, because all of them are from group 2, so beryllium has the smaller size, therefore it has the highest enthalpy change of the hydration. So that is A. Okay, so that is for number 10. So with analyzation, let's move on to the number 11. Diagram below shows shows a modern periodic table with some element represented by the letter. The element may not be the actual symbol. So if ionic compound PXQYRZ formed has the same ionic lattice structure, which of the following ionic compounds show the increasing trend in terms of magnitude of the lattice energy? Okay, so we are looking from the smallest lattice energy to the greatest lattice energy. So in here you can see P B is from group 1, Q R are from group 2, then Z is from group 16, XY is from group 17 here. So automatically this one will hold the charge plus 1, group 2 will hold the charge plus 2, Z will hold the charge minus 2, XY will hold the charge minus 1, and X is smaller than Y. Here, P is smaller. In terms of Q is smaller than R. So that is what you need to understand here. So the question wants to couple between PX. So PX is plus 1 minus 1. Okay. QY is plus 2 minus 1. Then RZ. So RZ is plus 2 negative 2. So of course, among these three, RZ have the highest lattice energy, then followed by QY, then followed by P. So the best solution in here answer is B. Okay. Okay, so this is how you're going to solve for question number 11. Okay, then we go to question number 12. Select enthalpy change of the combustion for ethanol, C2H5, carbon hydrogen, and carbon and hydrogen are given below. What is the enthalpy change of the formation for ethanol in here? Okay, so in here you can either use the Hess law, or you can even try to calculate using the formula total enthalpy change of the product minus total enthalpy change of reactant. But at the end of the day, you will get the answer as positive. But you should know that enthalpy change of formation is usually negative. So you can still use this method, but later you reverse the methods. Because it's objective, we are not looking for structure and assay. So you can still use this method, no problem. Okay. So negative 1290 is equals to 2 times x, 2 times negative 393 plus 3 times negative 286 equals to minus enthalpy change of formation for ethanol. So at the end of the day, enthalpy change of formation of ethanol in here is negative 354. Okay. Okay, so this one we use enthalpy change of the combustion formation product minus reactants in here. Okay, so hopefully you can understand how to solve this. Okay, so the answer will be C. Okay, and number 13, the T's energy of KCl and CaO are negative 34646 and negative 2815 respectively, although the interionic distance of the two compounds are about the same. Which of the following statement explain the big difference of the T's energy? So in here, you should understand that K and Cl is plus 1 minus 1. So CaO is plus 2 and minus 2. So we say that the T's energy is directly proportional to the charge and inversely proportional to the interionic radius. In the question, it already says that the interionic distance are about the same. So what will influence them? It is the charge here. Okay, so says it here that the charge has a much greater charge compared to potassium. So therefore, the best answer that describes the differences is because of D. Okay, okay, so that is how you are going to answer question number 13. So with that, that is for 13. Then we continue to question number 14. Okay. For 14, standard enthalpy change of the 1,2-ethane diols, OHCH2CH2OH, carbon and hydrogen is negative 1180, 393.7 and negative 285.9 respectively. What is the standard enthalpy change of formation of ethane 1,2 diol? So it's almost the same as how we solved just now. So here I show you using the Hess law technique. So 2 carbon plus 2 oxygen give 2 CO2, so 393.7 times 2. 3 hydrogen plus 3 carbon 2 oxygen give water, so you get 285.9 times 3. And then this one will reverse the equation already. CO2 plus 3H2O give 3CH2OH2 plus 5 over 2 H2O, and temperature of combustion is negative 180. So you can cancel in between here. 2 over 2O2 plus 3O2. Okay, so because you only have 1O2, sorry. So left 1O2 lah. Okay, so you cancel here, you cancel here, so no more. And then 2 CO2 cancel with 2 CO2, 3 H2O cancel with 3 H2O. Okay. So in here, at the end of the day, what do you have? 2C plus 3H2 plus O2 gives C2H2OH. Enthalpy change of combustion is negative 465.1 kilojoule. Okay. So the best answer in here is B. Okay, so that is how you solve for question number 14. Okay, number 15. Table below shows the size and charge for the 6 ion. Which of the following represent correct ascending order of the T's energy? Now in here, because you have different mixture, actually it's not CZ. Sorry, typing error. It's not CZ but CF. CF. Sorry for that. I wanted to type CF, but I accidentally typed CZ. Okay, so in here, in this case, you have made of different compounds. If you notice carefully, we have a few compounds such as AD, AE, CF, BE, BF. Okay, so if you arrange them carefully, okay, I'm going to arrange them in one shot. What else is not here? Difference BE, AD, CF. Okay, so there are 6. So if we arrange the 6, AD plus 1 minus 1, so the summation is also equals to so AD here I'm going to put 1 because time 1 minus 1. So the total distance in here is 0.350. Then AE here will be AE here will be plus 1 minus 1. Okay, negative also 1. And then inter-ionic distance is 363. In terms of CF plus 2 minus 2, so it's 4 lah. Okay, so in terms of the inter-ionic radius is negative 0.246. Okay, and then BE, so BE plus 2 minus 1, so it's 2 times 1, 2. Positive, negative, ignore it. 135 and 182, so this will give 0.317. And then last but not least is the BF. BF, BF in here will be plus 2 minus 2, so it's plus 2 minus 2, so it's 4 also. Okay, and then the inter-ionic radius is 0.200. So if we arrange them in terms of the lattice energy, you'll be AE, AD, BE, BF, CM. So ABCD, which one is the best solution? So the best solution here, according to the ascending order, is C. AE, AD, and then BF. Okay. So you try to arrange all of them in one shot so that you can easily see. Okay, so with that, that is how we are going to write determine the increasing order of the lattice energy. Okay. Okay, so with that, that is for question number 15. Then we goes to the next question, which is number 16. Which of the following is not required in the calculation of lattice energy of barium hydroxide, the Born-Haber cycle? So in Born-Haber cycle, we are going to use total enthalpy change of formation is equals to lattice energy plus atomization of barium, atomization of oxygen, the ionization of energy of barium, electron affinity of oxygen. So in here, it seems that hydration is not involved in the Born-Haber cycle. Okay. So the best answer in here is A. Number 17, which of the following has a positive value? So now in here, you have to know by yourself, what does all this equation represent? Okay, you can see in here, N2 plus 3H2 give 2 NH3, this is formation, and usually formation is negative. NaOH solid to become aqueous, this is enthalpy change of the solution. Okay, so if you ever do experiment, okay, when you remember or not, when we do one experiment, I asked you all to hold the sodium hydroxide when I dissolve in water. It feel what? It feel warm, isn't it? Warm, that means that it is exothermic. So this is exothermic. And then from gas to become liquid. So gas to become liquid is a condensation reaction. So condensation reaction release heat. So it is again exothermic process. And then CH3, CH2, CH2, CH3, gaseous molecule to become gaseous atom. This is atomization. So atomization is an endothermic process. So this is the only one which is the endothermic. So the best answer here is okay. So that is how you answer for question number 17. Okay, any questions so far? Okay, hopefully no one. Okay, then without annexation, we move to the next question. So the next question will be number 18. The radii of the 4 ion A, B, C, D are given below. Which of the following has the highest hydration energy? So we say that enthalpy change of hydration is directly proportional to the charge, yet inversely proportional to the ionic radius. Okay. No matter positive or negative, it is the same. Okay, so in here you look for the one with the highest charge, which is C or D lah. Okay, and then you look the one which is the smaller radius. Here it seems that D has a smaller radius, so the best answer in here is no D. Number 19, thermochemical equation for the reaction between nitrogen monoxide and ozone is as below. So if the activation energy of the reaction is negative 10.5, what is the activation energy for the reverse reaction? So in here, I'm going to draw for you the diagram. So in the energy profile, because this is an exothermic one, so exothermic reactant high, product low. Okay, so this process is exothermic, so negative 200. And then given to you, the activation energy is 10.5, isn't it? So what is the activation energy for the reverse reaction? So reverse reaction is from here to here. Okay. So in here is negative 200 plus 10.5. So at the end, your best answer is 210.5. That is how you are going to answer for question number 19. Okay, so hope it's clear for you. Okay, so we are going to go for the next one. Number 20. Industry ethanoic acid can be prepared from the oxidation of ethanol and oxygen. Oxidation, enthalpy change of the formation of ethanoic acid, water, and ethanol are given below. So standard enthalpy change of the formation for the preparation is what? So try your best to know on how to write the equation. So C2H5OH plus O2 gives CH3, CH3COH plus H2O. Okay. So the question already said ethanol acid can be prepared from the oxidation of ethanol with oxygen. So you must know, try your best to balance ethanol plus oxygen. So you have extra water, H2O. So H2O you must write out. So this is something that Stpm question will try not to tells you, and you have to balance the equation on your own. So these are the formula that you have to know. Okay, so sorry for that. These are true. You have to practice it through exercise. Okay, okay. So these are the equations. So you use total enthalpy change of the product minus total enthalpy change of the reactant. So negative 487 plus negative 286 is equals to negative 2878 plus 0. So enthalpy change of reaction is negative 495. So the best answer here is point B. Okay, then 21. Which standard enthalpy change of neutralization for the reaction between aqueous solution of sodium hydroxide and several hydrochloric acid is given below. Okay, so you can see in here, all of them has almost the same for HCl, HBr, HI, but HF is slightly different. HF is higher. We know that in the normal enthalpy change of neutralization, we say that H plus AQ plus OH minus AQ give H2O. If it is a standard one, it's negative 57.3, isn't it? But in the case of the hydrogen fluoride, it is very exothermic because only of one reason, which is donkey D. Okay, fluoride has the most exothermic enthalpy change of the hydration. Why? Due to the small fluoride ion size. Okay, so that is why the enthalpy change of neutralization is much more exothermic than expected. Okay, so this one I already explained in the notes, so maybe you can review back and when we discussed the enthalpy change of the neutralization. Okay, okay, so that is how you solve for question number 21. Okay, then it goes for question number 22. Which of the compound has the highest lattice energy? So K2O, KCl, CaO, and CaCl2. This is also a very direct question. So you should know by yourself that K2, KCl, CaO, and CaCl2. So K is from group 1, Ca is from group 2. Okay, and then O is from group 16, Cl is from group 17. So if you have CaO, is 2 times 2 lah. Okay, so definitely CaO will have the highest lattice energy. Okay, so this is for question number 22. Then we goes to 23. Standard enthalpy change of the several reactions are given below. Combustion of hydrogen gas is negative 286, and the combustion of the propane C3H6 is negative 1865. Enthalpy change of combustion for propane C3H4 is negative 1249. So calculate the standard enthalpy change of the following reaction. C3H4 give plus 2H2 gives C3H8. So in here you can also use the Hess law methods to solve. So if you use the Hess law method, you can start to cancel off among some of them already. already. So which one can be cancelled? If you notice carefully, O2 plus 4O2 is 5O2. So you can cancel 5O2. Okay. And we have 3 CO2 cancel with 3 CO2. 4 H2O cancel with 2 H2O and 2 H2O. So at the end of the day, you have CH4, 2 H2, and then C3H8. Okay. So at the end of the day, you just sum up all of them. Okay, you get positive 44 kilojoule. Okay, so teacher, can we use total enthalpy change of the product minus total enthalpy change of reactant? Yes, you can. You can use, no problem. And if you use total enthalpy change of the product minus total enthalpy change of the reactant, you get your answer as negative. So you go and think that the answer is negative, so you choose your answer as B. So this total enthalpy change of the reaction is equals to product minus reactant. It's usually suitable for you use formation to find combustion, but you want to use to find combustion to other things, then it is not wise for you to use these equations. So please bear in mind. Okay. Okay, so that is how you solve for question number 23. Immediately we go to 24. Standard enthalpy change of combustion for methanol is negative 690 kilojoule per mole. Which of the following is the equation combustion? So the combustion equations for methanol is CH3OH plus 3 over 2O2. If CO2 gas plus 2H2O also gas. So after combustion, the water form is actually in gaseous form. So the best answer here is not PD. Okay. 35. Standard enthalpy change of formation of water is negative 286 kilojoule per mole. Which of the following statement is true? Okay, so with it means that standard enthalpy change of the combustion for hydrogen gas is negative 286 kilojoule per mole. So even though there is some unorthodox way, but because the answer is here, so we're going to assume number one is correct. But actually, number one is not correct, to be honest. Hydrogen plus oxygen give H2O gas, I would say. Okay, but in this case, because of the selection, so we're going to assume that number one is correct. Okay, sorry for that. Number two, therefore it is the same with hydrogen. In the reverse reaction, 1 mole of water is required positive 286 kilojoules. So 286 is correct. Okay, and then standard enthalpy change of atomization for water is 286, which is wrong because atomization is atomization is formed at top. Here I'm going to write the equation. You shall have H2O liquid will dissociate to give 2H gas plus O gas. So it is different equation already. So it's not equals to 286, so 3 is wrong. And then enthalpy change of reaction H plus plus OH minus give H2O. This is neutralization. So neutralization is 57.3. So 4 also wrong. So the best answer in here is 1 and 2. Okay, so this is for 25. Immediately we go to 26. This energy is influenced the solubility and melting point of ionic compound. Which of the following is the order of decreasing lattice energy? So we are looking for decreasing lattice energy. So in here you should know by yourself, Mg and Ba are from group 2, so they have +2 charge. O is from group 16, Cl is from group 17. So oxygen has 2 minus, Cl and they have minus. So in terms of the highest, MgO will have the highest lattice energy, followed by BaO. Then BaCl2 we have a smaller MgCl2 we have a smaller lattice energy, and then BaCl2 we have a smallest lattice energy. So this is the order: MgO, BaO, MgCl, BaCl. So the best answer here is A. Okay, 27. Enthalpy diagram below shows to represent the anhydrous calcium chloride in a large volume of water. So this you have to know by yourself that this is the lattice reverse of the lattice energy, negative lattice energy, and then this one is the enthalpy change of the solution, and this is the enthalpy change of the hydration because from gaseous atom to become aqueous, so it's hydration, and then solid to become aqueous is solutions. So make sure clearly. Okay, which of the following statement is correct? Number one, lattice energy of the calcium chloride is negative 2526, which is actually correct. Okay, and temperature of hydration of chloride ion is 384. So here this is hydration. So 2 times, that means 2 is belongs to the Cl. So the Cl is negative 384, also correct. And temperature of solution at hydrous is negative 132. So if you calculate properly, solution is negative 189 plus 2 times negative 386 minus negative 2526. You get negative 132, which is also correct. And calcium chloride is insoluble. In here is wrong because negative value indicates that it is soluble in water. So calcium chloride is soluble in water. So the best answer in here is E. Okay, straight away we go to question number 28. So 28 sounds like this. The following equation each represent the steps in one-Haber cycle of the lithium ion. So which of the following has a negative value? So we say that enthalpy change of the formation is equals to lattice energy plus whatever summation here lah. Atomization of lithium, atomization of oxygen, lattice ionization energy of lithium, first electron affinity of oxygen, second electron affinity of oxygen. So in here I label all of the process which are endo or exo. So since we are looking for negative value, so we are looking for exo lah. So here it is a formation which is exothermic here. Okay, number one is second electron affinity. This is second electron affinity, which is exo, endo. Sorry, this is atomization. So this is endo. Solid to liquid. This is atomization. So this is also endothermic. Okay, so the best answer is A. Okay, then for 29, standard enthalpy change of the combustion butane C4H8 is X. Then the enthalpy change of the reaction 2C2 plus C4H8 is Y. Y is the standard enthalpy change of combustion for butane. So in here you write the equation. C4H6 plus 6O2 give 4CO2 plus 4H2O. So this is X. This is X. And then 2C plus C4H8, this is Y.